Hello. Okay, just a quick review from the last four problems. If we look, or five, if we look at this, number 7, you have y up here on top divided by x, and so that's going to be an inverse variation. All right, and here you have y on top, and then you have x on top, so that would be a direct variation. And then here you have y, x, and z all in a row, all on top. All right, so if one gets bigger, y is going to get bigger. If z gets bigger, y gets bigger. So that would be a joint variation. And then here you have x times y equals a constant, equals 3. So when you multiply two numbers to get a constant, that would be an inverse variation. All right, because to keep this constant, if x goes up, y has to go down. And for number 11, you have 3 variables. I've got y, z, and x. All right, so that's going to be a joint variation. If I move the x over, right, I would multiply both sides by x. And if I have one in top and one in the bottom, they cancel out. So I have y, z, and x all on top. Okay? All right, very good. And then the constant here, that 10 would be k. This constant would be 1/4. All right, the constant here is this 7. I kind of hit it. There's k, is that constant. Here we said k is 3, that constant. And then this constant, well, this 2 is over here by the y, so I would have to divide both sides by 2, so that goes away. So that would be k equals 1/2 for my constant. All right, so now we're looking at word problems, and we're going to cross out, and we're just going to write the equation for the variation. So I've got the volume of a mass. All right, so I've got volume. I'll call that V. And it's at a constant temperature, so I've got a constant variation here, and it's inversely proportional to the pressure. All right, so if it's inversely proportional, so I've got P. All right, so I'm going to ignore this for the time being because it's constant, right? I don't have to worry about it. It's the volume that is inversely proportional to the pressure. So inversely, remember your equation would be K. Oh, or not K. Y equals, and actually let me just erase this and you can look at it. I've got y on top, that would be inverse, right? Y on top equals my constant, and then x on the bottom. So that's an inverse variation. So the volume of mass is inversely proportional. Oops. Okay, so, but it's inversely, there's no x here. What it is the pressure, right? We're talking about pressure. So I'm going to, instead of x, I'm going to put P for pressure. So volume is inversely proportional to the pressure. So you have volume on top, because this would be like V over 1, and pressure on the bottom. All right? And then I have my constant here. All right? And so, yeah, I could put T here, I guess it's constant. But the main thing is the volume is it looks like this, right? Volume and pressure here. So what that means is if the pressure goes up, right, or if I want to increase the pressure, I've got to decrease the volume. And we know that if you squish something, you increase the pressure, right? If you squish something, then you decrease the volume, and so the pressure is going to go up. If I take the lid off of something, all right, if I want to lower the pressure, right, if I want to lower the pressure, I would increase the volume, so I would take the lid off, right? So there we go. So we'll just leave it like that without the 1, and that would be an inverse proportion. All right, so we're just going to put variables in for the words. We can make up our own variables. So here we have the resistance. So all you active physics people, this should ring familiar. So you have resistance of a wire, right? And it says varies directly. Oops.
I just went ahead and made a whole pile.
Oh. Okay, so the resistance of a wire varies directly as the length. All right, so that if we look, oh, we can't see it anymore. So, but we know that they're going to both be on top. I have my constant, and then the length, we'll use L for length. That makes sense. All right. So, if the length of your wire gets longer, you're going to have more resistance. All right, and that makes sense. The electrons have to go farther, so there's a lot more to go through. So, and now inversely, and then we also have this inversely down here, and inversely. So inversely, I'm going to have a fraction. So that's no big deal, all right? And then that means the square of the diameter goes in the denominator. So diameter, we'll just make that d, and then we're going to square it, so that would be d squared. So I'm going to put d squared in the denominator. So that would be an inverse variation, and that makes sense too. If I want to, if the diameter of the wire is a really skinny wire, all right, so if I decrease the diameter, it's a very thin wire, that's going to increase my resistance, right? It's harder for the electrons to get through a skinny wire, all right? But if I have a really thick wire, a big diameter, all right, if I increase the diameter of my wire, so it's a big, thick wire, or then I would have less resistance. The electrons can move more freely. All right, so you can have both of them going on there at the same time. All right, so now we're going to write an equation and we're going to solve it. All right, so we have the electrical resistance, so we have R again, right? Ohms is the unit for resistance, and it says varies directly, all right, as the length. So that's just like the one we had before, right? L is length. So R equals some constant times L, right? But now we're solving a problem. So what I want to do is set up a proportion, right? And so I'm going to try to remember how to get that constant by itself. All right, so that would be, the constant is R divided by L, right? And remember, varies directly, you divide. All right, so R over L. So I'll set up a proportion. That makes it easier to solve problems. And so now I have a wire that's 9 meters long. So that would be L, so 90. I mean, that goes in the bottom. And then the resistance is 6 ohms. That means ohms. So the resistance is 6 ohms. So resistance, remember, is on top. All right, so those go together. That's one situation. And then I have that other situation here is the resistance, or it says, what is the resistance? So that I don't know what the resistance is. So that's my R. But I do know that it's 150 meters. All right, that's the length of it. So I have a longer wire. Right, so what happened is I have a longer wire. So we would expect, if in a direct relationship, they both go, if one goes up, the other goes up. So longer wire, more resistant. So let's cross multiply. And we've got 90R equals 6 times 150. So we'll come over here and we'll do 6 times 150. And we get 900. So 90R equals 900. And then you divide by 90, divide by 90. And so you get R equals, that cancels out. And then 90 divided by 9 is 10. And then the unit for ohm resistance, remember, was ohms. And this is a word problem, so you use your units, right? So 10 ohms is my answer. All right, fantastic. So you can do a lot of you can solve problems in any field using these variations in proportion. So now we have another physics problem. We have the speed of an object falling from rest. So the speed of something, that's the velocity, right? And that would be meters per second for our units, right? That's what that is right there. And it's directly proportional to the time. So we'll use T for time. So directly proportional means they're both on top. I have some constant and then I have time. That's direct proportion. All right. If the velocity, if it's falling for longer in a longer amount of time, then it's going to be going faster. And that's why it hurts so much if you fall from a high place, because you're going faster and faster and faster. And then we are solving a problem. So I want to get a proportion. So I'm going to get the K by itself. All right. So I have volume, direct is, remember, you divide. So I've got volume over, not volume, velocity over time equals velocity over time. All right. And then I'm going to substitute what I've got. So it's fallen for 2.5 seconds. That's time. So that goes in the bottom. And after 2.5 seconds, the speed is 24.5. So the velocity is 24.5. And those are the meters per second. All right, that's a hint. That's the velocity. So, and now it says, what is the speed? So I don't know the speed, so the velocity is my unknown. And it's fallen for 4 seconds. So my time is 4. All right, so we went from 2.5 seconds to 4 seconds, so the time increased, right? So like we said over here, we're expecting that the velocity, if the time increases, that the velocity is going to increase. So let's cross multiply, and I'll get 2.5v equals, and then I'll take 4 times 24.5. 4 times 24.5. All right, I get 98. Now I want that b by itself, so I'm going to divide by 2.5. So I get 98 divided by 2.5. All right, so I've got the 98 there. If I just hit divide, it will automatically write that answer there. So it's going to divide the 98 by 2.5. Enter. You get 39.2. So v, my velocity, is 39.2. And then again, units, because it's a science problem, so I'm going to say meters per second. And the units help you. That helps you know that you got it right, actually. The units are your guide. So, and we did. The velocity did increase. It went from 24 to 39. All right, so that's, again, that's another way to tell that we did it right. Okay, good job. Now let's look at these tables.